Hello, good evening, Amitabh. Am I audible?
Yes, sir, you're audible.
Oh, thank you, Shubham. How are you?
I'm good, sir. Barun sir has joined. Mr. Aggarwal has joined.
Hello, good evening, Mr. Aggarwal. Mr. Aggarwal, am I audible to you?
Yes, absolutely. Very good evening.
Good evening, sir. Good evening. Welcome to the Isha Kolkata chapter.
Thank you so much.
This is Manish Tiwari. I'm the president of the Kolkata chapter here. Good to have you here with us, sir. Good to have you here.
Pleasure to be there. And I don't know if you know this or not, but I was born and brought up in Calcutta, so very dear to my heart, everything
Oh, great.
related to Calcutta.
Great. So where did you do your schooling from?
St. Xavier's School.
St. Xavier's. Okay. I was very near to your school, Birla High School. I did my schooling from Birla.
Yes, of course.
So which year did you pass out?
I graduated class 12 in 1992, 93, and college in 96.
Nice. Oh, great. So I passed out in 88.
Okay.
Mr. Shanko Bhattacharya is here. He is the chapter's secretary.
Hi, sir. Good evening.
Very good evening to you, sir. How are you?
Fine, sir. We are glad.
And we also have Mr. Amitabh Datta. He is the program chair. Amitabh, are you there?
Yes, sir. I'm there.
Yeah. Okay. Sir, what we have generally planned out that we would be starting with a small introduction by me, and then there will be some Ishre videos which are mandatory to run. So those couple of videos will run, and then Mr. Shanko Bhattacharya would be doing the welcoming address and giving your profile, reading out your profile to the whole team. And then we'll hand it over to you, and we'll share the rights with you so you could do your presentation.
Perfect. Sounds good. Thank you so much.
And then there will be a post that there will be a Q&A session. So that our President-elect Nilanjana, she will be conducting that. So would you want the Q&A session to be the questions to be directly asked? Generally, what we do is the questions are posted on the chat box, and the officiating person is actually going about it. And otherwise, also at certain questions which have follow-up questions, we encourage the speakers to themselves come online and talk about the questionnaire. So this is generally we follow, and would that be okay with you as well?
That's absolutely fine. No issues at all.
Okay, fair enough. Thank you. So we'll take it up from there. We still have some time, I think another 10 minutes. Hope to have a good session, sir.
Thank you. Look forward to it.
Good evening, Manoj sir.
Manoj sir is here. Great.
Good evening.
Good evening, sir.
Good evening.
Good evening.
Good evening, sir.
How are you?
I'm fine. How are you?
Very well, thank you, sir. Thank you again for having me here. It's a pleasure and honor to be here with you, all of you.
Yes, Barun. And we are also lucky to have you within us today.
Not at all, sir. My pleasure, my honor. And I had promised you a little bit of a fresh presentation.
Yes.
So this is made literally finished. I finished it today. So there's a fair bit of fresh material here, but taking a lot of learnings from the last year and a half from some of the best speakers around the world, some of the best scientists around the world, taken all their learnings, and I've tried to put it all together. So hopefully this should be a little bit interesting.
That is the reason why we want Barun to be here. We know that we will be getting the best of this type of pandemic situations, which will be appropriate. And that is the reason we were really lucky to have you.
Thank you, sir. Thank you.
Thank you, Barun.
Manoj sir, how are you doing, sir?
I'm fine so far. How are you?
Okay, great. Good, sir. Good. Thank you for joining, sir.
Sure.
Have the monsoons hit Kolkata already?
I normally
Yes.
try not to miss Barun's this thing, presentation.
Yeah.
I like it. I can still remember in 2019 our record. Barun's presentation was, as per me, was the number one.
Oh gosh.
Also, we have the speaker from Canada, we have the speaker from Europe and all these places. But I'm telling you, your presentation was really fantastic.
Thank you, sir. Too much pressure on me now.
Even now also people used to refer.
Acha.
Till now, and people used to like it very much. Mainly our delegates from Bangladesh and other parts, they really liked it.
So I'm going to reach out to you about that. We're looking at opening a small office in Bangladesh.
Yeah.
I'll reach out to you to see how I can connect to some of the counterparts.
We have the Israelites and Bangladesh, and only because of this pandemic situation, and we could not charter that subchapter. It is on the Calcutta chapter. I think they are planning to have a installation through this thing, digital way. And when the situation will be normal, then only the chartering, official chartering will be done by handing over everything.
Okay.
We have around 25 members.
That's very nice. Okay. Interesting. I'll separately.
It is in the name of Israel.
Very nice. I'll separately reach out to you to talk about this. There is a couple of questions I have about this. I'll call you separately.
Whenever you feel like, you just tell me, I will. I'm there.
Perfect. Thank you.
Yes, Barunji, the monsoons have hit Calcutta and hit in a big way. I mean, we were waterlogged for the last day before yesterday. The whole city was waterlogged.
Oh, really?
And it is continuing to rain even now as we speak.
Oh,
so things are better yesterday, little drier spell, but today again we have our overcast skies and a lot of rain. So in a way it is good, but then quite a bit of waterlogging. The first big rain hit us day before yesterday.
Some things haven't changed, that means. I remember the water from my days in the
Yes. So it has reduced. It has definitely reduced. It's not as much as what it used to be earlier. But then, of course, once the first rains hit, then I mean, it was very bad day before yesterday.
But weather forecast told that today is the last day of the rain.
Hopefully, sir. I mean, for this spell, maybe,
Yeah. This spell.
Fair enough. Calcutta is supposed to hit tomorrow. Delhi is supposed to hit tomorrow. So we're waiting for the rains over here.
Yeah. Actually, from Kerala, it comes to Calcutta normally.
Correct. It goes around this way.
Yeah.
Hi, good evening, everybody.
Good evening.
My name is Sunil Kanal. I am presently joining from Dubai.
Welcome, Sunilji. Good evening to you. Welcome.
Mr.
It's a pleasure having you here.
Thank you, Mr. Chakrabarti. Thank you, Mr. Tiwari. How are you doing?
Great. So nice of you to joining us over here. How are you doing in Dubai? Dry, very dry there, I presume.
Yeah, it is quite warm, and summer has already set in almost literally 1 month back. But yes, this is the way it is. It's quite dry. That's true. Very, very correct. But having said that, we just can't travel. I mean, it's been 2 years that we have not been traveling at all because of this pandemic. So, and again, even one can travel because all the flights have resumed from Dubai to literally all over the world, not everywhere.
Yeah.
But unfortunately, coming back from India back to Dubai is very limited. So that's the reason we have not been able to travel at all. I'm sorry, not for 2 years, but for a little more than 1.5 years, I would say.
I agree, and I hope that this time with the vaccines and all, another maybe couple of months, and then we should be able to do the traveling bit.
Well, let's hope so. Let's hope so, because the way things are happening, the virus mutating, it is so dangerous. People are not. Just today, I heard from Mr. Guleria that the third wave is inevitable. First time they have mentioned it, and he's expecting somewhere around 4 to 6 weeks from today. So this is even more scary.
I agree. Things are pretty scary out here in India. The only good part is that the vaccinations have started in earnest, and this time I think both government agencies as well as the people in general are going to be more cautious. But I think that everyone has got the idea as to how bad things can turn out.
Yeah, I will tell you one thing. Government may try its level best, but it's up to an individual and the people who need to understand, so somehow or the other, we are just not bothered because of our very, what shall I say, very bad mindset we have. I mean, chalta hai, sab chalta hai attitude. This is not correct, actually. And this is precisely the reason that I believe that, we have not been able to conquer this, even the second wave till now.
Yes, very correct, sir. Very correct. It's a pity, and but then the fact also remains that we are a very big country with a huge demography and a huge population. So under the circumstances, I feel things were very scary, but luckily we have been able to contain it somehow. And I hope that the future would be rather better than what we've had. The worst is behind us. That is our hope and prayers, I mean. That is what.
Let's really hope so. That's fantastic. In fact, just to give you a little bit background, very, very extremely brief background is basically I work for a company called Magenta. It is my own business for the past 1 decade. And we also cover indoor air quality and real-time monitoring solutions for energy as well as air quality. We are able to see what is happening inside 4 walls on a real-time basis, and accordingly we suggest the solutions for the clients, whether it is for the energy consumption or for the indoor air quality. So it is basically the solution goes on the client. If the client wants us to give the solution, we can give. Otherwise, we leave it to them. They can have their own contractors. They can have their own people to go ahead with their requirement. So this is what we have been doing for past 1 decade on the energy front as well as indoor air quality. And so this particular session, when I got in, when I came to know through the LinkedIn, I said, let me just go ahead and do it, because I normally attend all the air quality. That's how you equip yourself with knowledge. Unless and until you attend, you'll never come to know how good you may be or how bad you may be. It's only learning which really helps you to grow your knowledge. So I said, why not? Even if we are talking, it's good to understand something, learn something from others, because you are by yourself, you do not know anything much. Only when you, as a collective effort, you will learn something new. So that's the reason I'm here today.
For sure.
Agree. Thank you. Thank you very much. Maybe in a near future, Kolkata chapter could arrange a product presentation for you. Coming back to the topic at hand today, I think it's about time, and we have about 40 odd participants already on board. So I would like to officially start this session. Welcome to Mr. Barun Aggarwal, who we have today, one of the top consultants across India, and his specialty is indoor air quality. And we are at the Kolkata chapter are really happy to and proud to have him with us today. And we hope, and I'm sure that we'll have a great session, as Manoj sir had just pointed out, that Barun sir's presentation in our last recon is fondly remembered by everyone. So without wasting much of time, I would like to request Mr. Amitavo and Mr. Shubham Banik, our chairs for the program and the youth chairs, to carry on this evening forward. Over to you, Shubham, please.
Good evening to all. Good evening, Manish sir, and good evening, Barun sir. So to start with, we have to follow a custom of playing the history video. So let us find out what history is all about. So with this very small video, and I'd request Siddhartha, our from our backend team, to kindly play the history video. And I'd request one thing before starting, kindly keep yourself on mute. Only if you have any questions, you can unmute yourself and ask the question. Otherwise, it disturbs the flow of the event. So that is the only request we have from our program team. So over to Siddhartha, kindly play the history video.
Before that, I would, hello, am I audible?
Yes, Sanko sir, yes.
Before that, I would like to introduce Mr. Barun Aggarwal to the delegates, participants. So I would just request that history video to run after this welcome address to Mr. Aggarwal. Distinguished delegates, participants, members, students, and friends, hello everyone, and welcome to today's evening session. Even in these difficult days of COVID pandemic, it is a glorious moment to extend our warm wishes on behalf of ISRE Kolkata chapter. We want to convey our heartfelt gratitude to our today's expert speaker, Mr. Barun Aggarwal, for accepting our invitation and presiding over this webinar on indoor environmental quality. Just for the participants who may not be aware, Mr. Barun Aggarwal did his schooling from St. Xavier's, Kolkata, and we are glad to have him today on this occasion. Welcome to you, sir, in this virtual mode. It is an opportune moment to refurbish upon the technicalities of indoor environmental quality with Mr. Aggarwal for this evening. The webinar scheduled brushes upon the standards of indoor environment and its qualities. With his vast knowledge, experience, and passion, we are confident that you will find the session very appropriate, informative, and productive. We request you to kindly post your questions or doubts in the chat box. Relevant questions will be answered by the lecturer only after the session. We wish you all a very successful webinar. Thank you, Siddharth. You can take it up.
Thank you, sir. Thank you.
We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems, and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests, and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC&R industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVAC&R and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation, to enter and explore the universe of the Indian HVAC&R industry. Log on to ishre.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRE.
Thanks, Siddharth. As per the protocol, we have run the full video of ISHRE to showcase the benefits of joining the society. So those who are still not members can join the society and serve the society along with us. Now I would request you to run the theme video of Lakshya for this society year 2021, guiding and directing our activities towards the goal. Siddharth. Thank you, Siddharth. Thanks to ALP Group, Lloyd Insulation, Universal Sales, and Contromerce Technologies, our sponsors, for their valuable contribution to the society. Please just
Thank you, Shankar sir. Yeah. Shidut, please display our partners. Once again, we thank all our partners, LP Insulation, Universal Sales, Compromised and Lloyd Insulations, Compromised Technologies and Lloyd Insulations. Now, let us play the disclaimer slide. So this is basically the disclaimer. Shidut, can you do that? Yeah. Would request everyone to have a look at the disclaimer slide. Thank you. With this, the introduction part is comes to an end. So now I request Barun sir, Mr. Aggarwal, you can kindly go ahead with the rest of the session.
I will just give the brief introduction of Mr.
Oh,
Aggarwal.
you've missed. Okay, yeah.
Mr. Barun Aggarwal is the founder and CEO of Breathe Easy Consultants Private Limited. He has co-authored a book, How to Grow Fresh Air, published by Juggernaut Books. He serves on many national and international boards and committees to create standards and policies on air quality. Among them, he is the chapter director for IAQA, Indoor Air Quality Association, India chapter. Mr. Aggarwal is the founding member of the Indian Environmental Quality, that is the IEQ Committee of ISHRE, that has developed the first international standard for IEQ. He is also the technical group chair for indoor air quality under ISHRE and the member of COVID-19 HVAC Guidelines Committee. He has also served on Indoor Air Quality Assessment Working Group of the United States Green Building Council. He is a climate reality leader trained by former US Vice President and environmentalist Mr. Al Gore. His passion for the environment takes him around the world to speak on air quality, water quality, and climate changes. He teaches a course on human wellness in the built environment at the School of Planning and Architecture, New Delhi, as a visiting faculty. Mr. Aggarwal is even more passionate about the social impact of outdoor air pollution and has co-founded an NGO, Care for Air, that creates awareness about air pollution and its health effects in India. The goal of Care for Air is awareness, advocacy, and change. He takes the message of air pollution and climate changes to the school children across India. A big hand for our expert speaker, Mr. Barun Aggarwal. I would now request Barunji to take charge of the virtual stage for today's technical session. Thank you, sir.
Thank you so much, Mr. Bhattacharya, Mr. Tiwari, Manoj Chakravarti da, for having me on this wonderful platform. It's a pleasure. It's an honor to be here. As I mentioned earlier, Calcutta is very close to my heart because I was born and brought up over there. So it's really feeling like I'm back in Calcutta presenting to everybody over here. So thank you again for giving me this opportunity. I'm sharing my screen now. Please do confirm that you can see my screen in presentation mode. Is my screen visible?
It is visible. Yeah.
Okay, perfect. So the topic of today's presentation is indoor environmental quality, and I'm focusing more on the air aspect of it in COVID-19 times. And it's a slightly different perspective, a lens into human health. And I'm going to challenge everybody over here, everybody in ISHRE that comes onto this platform, it goes away learning something, whether you're and most of us are engineers, some of us are not engineers, But most of us, when we come into a platform like this, we come in to learn and to network and to build our capabilities. So I'm going to push you in a slightly different perspective, because up till now we've been talking about air conditioning and HVAC from a comfort perspective. Today we're going to talk about all of those things, but from a slightly different lens, from a human health perspective. So the introduction is over, so I'm going to skip that slide. And I just want to put a quick special thanks and acknowledgements over here. I've learned everything about air quality in the last 10 years or so, or a little under 10 years, from various leading scientists, specialists, and experts in the fields of IAQ, outdoor air quality, climate change, and HVAC engineering, who have helped me gain a deep appreciation and understanding of this topic, and have helped me even craft this presentation today. Of special note, I want to mention Dr. Joshua Apte, who currently teaches at the University of Austin in Texas and moving to California. Dr. Sarath Gutikunda, one of the leading air quality scientists in India. Dr. Kirk Smith, Dr. William Barnfleth, many of you would know of him from ASHRAE. Dr. Ian Cull, Dr. Marwa Zatari, I've had the pleasure of working with her on various projects as well. Mr. Kamal Mittal, many of you would know him as an environmentalist and also my father-in-law. And I've been personally trained by former US Vice President Al Gore. And there are many others that I just want to say thanks to, because I have really learned a lot in the last 10 years and hopefully making a little bit of a difference. So I want to start by, we're talking about COVID-19. So I just want to talk about the history of viruses, and especially the SARS or the coronavirus history. It was first reported as SARS-CoV in 2002. Then it was the MERS COVID in 2012. And now in 2019, it is COVID-19. So this tells us, history tells us, that this is not a one-off event. Yes, the magnitude of this event is probably one-off in our lifetimes, but similar events like this will probably come again in the future. And we need to be prepared so that we don't go through what we have gone through in the last year and a half, and probably will continue to go through in the next few months. So my first question that I like to ask everybody is, complete mitigation possible? I'm going to be talking about indoor air quality. I'm going to be talking about measures that you can take to reduce the risk. But the key word over here is reduce or minimize the risk. Is complete mitigation possible? And the answer is probably not. One will still need to take all the precautions in terms of distancing, in terms of masking, even after you've taken as much of the precautions that I will talk about later in this presentation today. And from the numbers perspective, you can see, I've been putting up this slide from Johns Hopkins University over the last year and a half. I've been doing multiple presentations. And when I started doing this presentation about a year and a half ago, India was very far behind on the list at some 120 position. Slowly, India started climbing the ranks, and it moved in the top 100 to slowly to the top 50, then the top 20, and then the top 10. And then slowly it moved its rank up to 9876, and now it is up to number 2 in the world in number of cases worldwide. It is a pretty close second as of now to the United States. And given the United States has very aggressively vaccinated, with the third wave that we just heard Dr. Guleria has confirmed, and it is very close upon our heels, I think India is poised to take on the pole position and the number 1 position in the number of cases in the world. It's going to be a grim milestone, but it is our responsibility as engineers to try and see what we can do to minimize the spread in indoor spaces, because as a country, we cannot afford to stay shut economically for a long period of time. And hence, the sooner we understand what needs to be done to keep ourselves safe, the sooner we are able to explain that to our clients and get them to implement solutions to stay safe, the better off we will be. So, well, somebody is trying to scribble on the screen. Can I request you to stop that, or how do I clean that?
Sir, kindly reshare the screen. It will be automatically omitted.
Okay, sorry about that. Okay, so like I said, I'm going to push you out of your comfort zone. Everybody right now is in a certain comfort zone. We know our HVAC, we are experts in engineering, we are experts in air conditioning. And some of us know a little bit about air quality. Some of us know a lot about air quality, but I'm still going to push you outside of your comfort zone. And I'm going to take you into the area where we are going to start designing for health rather than just for comfort. And designing for health means that we have to take into consideration comfort, which we all are aware of, but we also have to take into consideration air quality. We have to take into consideration the environment. And from a holistic perspective, think about human wellness. And human wellness is one of the most critical things that we're going to be that is going to be the future. And we're going to understand why that is the case. So well or wellness is for people. At the end of the day, why do we make buildings? We don't make buildings for the sake of making buildings. We don't make buildings to put air conditioning into buildings. We make buildings because we want people to be inside those buildings. We want people to live in those buildings. We want people to work in those buildings. We want people to be productive inside those buildings. And so well is for people, and that's what we want to design our buildings, and we want to design our systems so that people are living in health and wellness. And we spend 90% of our time indoors, right? Whether you're in your home or your office or your vehicle, which is also an indoor space, or in a restaurant or in a gymnasium or in a hotel, 90% of your time is spent indoors. And we have the ability to unlock human potential with our buildings. And it is our responsibility, again, as engineers, whether we're designing the building, whether we're the MEP consultants, or whether we're just the air conditioning experts, it is our responsibility to ensure that we give the maximum benefit to the occupant of that building so that we can unlock their maximum potential. So this was a study done by McKinsey and Company, one of the leading consulting companies in the world. And they said that the trends all point in a single direction. More and more consumer spending is going to be on health and wellness. Wellness is the next $1 trillion industry, trillion, my friends, with a T. As employers invest in healthy living programs and as customers take more responsibility for optimizing their own health. So wellness is where the future is. And that's why I'm focusing this presentation around wellness. And I'm just putting this slide out there. This is all these, a couple of these slides are thanks to the Well Building Institute. I've taken permission from them to use these slides. But essentially, a few of these outcomes are very important to understand that what are we trying to address when we design buildings for wellness. So from an occupant health outcome, we're talking about headaches, eye strain, skin irritation, infection, fatigue, asthma, stress, etc. From a perception outcome perspective, it's perceived physical health, my perceived psychological health, my perceived productivity, how productive am I in my space? And finally, from an organization perspective, we're also worried about the outcomes from a financial perspective, which are absenteeism, staff turnover, revenue, medical costs, cost of insurance of that facility, etc. All of those will have an impact depending on how we design our buildings for wellness. And the last slide from the US Green Building Council, the Well Building Institute, is about investing in people for return on investment. And this is a very, very telling slide. If you take a building and you look at a business that may perhaps own a building, you will realize that the energy cost of that building is approximately 1% of the entire operating expense of that business. Rent and operations are typically 9% of that entire cost. And the balance 90% of the entire cost of that operation, the business cost, is salary and benefits. So if you can improve the productivity of your people by 10%, you will have made a 9% difference to the bottom line. Whereas if you improve your energy by 10%, you will have only made a difference of 0.1% to the bottom line from a company perspective. So invest in your people and you will get the highest return on investment. And that is why we're going to talk about why wellness is important and why people are important in the space. So coming back to COVID-19, and I'm going to link these now, right, about wellness and COVID-19 and how we're bringing them together, and based on that, how we have to now design our spaces. So the World Health Organization earlier, when COVID-19 hit us early last year, had said that COVID-19 was based on droplets. And very recently, just a couple of months ago, they finally accepted that it's not only droplets, but it's also aerosolized. Aerosolized means that it can get suspended in the air and stay in the air for many, many hours. So in a closed room, if you don't have any ventilation, you don't have any movement of air, if those aerosols can stay hanging in the air, the density of those aerosols or the viral load can go very high if a person is already positive and asymptomatic. And somebody else walking into that room, when that person breathes, there's a very high likelihood that the viral load that they will inhale will be very high, and they could potentially get infected. And that is the whole problem with aerosolization, and hence mechanical interventions in terms of design of your HVAC systems and from air quality perspective become very, very important. So, like I said, WHO finally agreed that COVID-19 is confirmed as airborne and can remain for 8 hours in the air. Now, whether that's 8 hours or 20 or 6, it doesn't matter. The point is that in a closed space, it can stay and remain airborne in the air. So everyone is required to mask everywhere. That was one of the breaking news. So what's the difference, whether it's droplet transmission or airborne transmission? So if it was droplet transmission, then surface sterilization becomes very important. Fogging becomes very important. Your importance on hygiene is very important. All the high touch areas in an office, your door handles, your microwave, your pot for tea or for hot water, all of the points that are touched by people become very critical, and those sterilization of those surfaces becomes very important. However, if it's airborne transmission, then you have to reduce the exposure from inhaling. And inhaling, you can't stop the inhalation. Anybody who comes in has to breathe. And so how do you reduce that exposure? 1, by ventilation. 2, by filtration. 3, by reduced time exposure. So reduce the amount of time you're in that space, which will reduce your viral load exposure. And eventually, also, you want to reduce density. That's the reason the government comes out with guidelines saying only 50% occupancy is allowed in an office, or 25% or 70%, depending on the situation, because they're trying to reduce the density within that occupied space. So the big question is, how do I know if my building air is safe right now? It's a highly complex, full of uncertainty, most critical question, and yet it is difficult to answer. But we're going to try and see if we can answer this, because knowing that my building air is safe has become a very important question in the minds of many C-level people in organizations and also administrators, because they want their offices to open, they want their people to come back to work. So the 3 things, as I was part of the COVID guidelines document of ISHRE, the 3 main things that can be done are ventilation, filtration, and disinfection. And we'll talk a little bit about each one of these in terms of what it means to ventilate a space, what it means to put proper filtration, and what it means for disinfection. So coming to ventilation and airflow patterns. Oops, sorry. So ventilation is probably one of the most critical and one of the most important things that one can put in place in their facilities, whether it's home or an office, because dilution, many of you may have heard the term, dilution is the solution to pollution. So by diluting your air, by bringing in air from outside, you are diluting the pollutants inside. The viral load can be diluted, all the other pollutants can be diluted, and that can reduce the risk of transmission from one person to another. Another very critical aspect that I learned recently from a very senior ASHRAE fellow is with regards to airflow patterns. The airflow patterns can become very critical when designing a space. So where your supply ducts are located and where the return ducts are located in a space can have a huge impact in terms of the flow of various pollutants and the flow of air within the space. And that can have a huge impact in terms of transmission of virus within the space for various occupants. Your options are mechanical or natural ventilation. In natural ventilation, you just open your windows and you allow the air from outside to come in and dilute your air indoors. And mechanical could be either an exhaust system or a forced air inlet system, which is ensuring that the air indoors is diluted. keeping ambient local air quality in mind is important when designing ventilation systems, because if the outdoor air is extremely polluted, and I'll take you to, we'll talk about that in the next slide. But again, I just want to talk about the viral load. I talked about it a little briefly in the past, but viral load, also known as the viral burden, is a numerical expression of the quantity of virus in a given volume of fluid, including biological and environmental specimens. Now, essentially, when I'm breathing out, if I am an infected individual, the viral load coming out of my mouth is going to be very, very high. But as the air gets diffused when I'm breathing out into the air, the viral load from a volume perspective starts to reduce. And that's why the distance of 6 feet or more is recommended, because the viral load will reduce as the air diffuses in towards the 6 feet marker. And as there is ventilation in a space, that viral load will further reduce, because the dilution will happen by bringing in air from outside, which hopefully is not contaminated. So the viral load is a very important factor in transmission. If you do get exposed to someone, but very low viral loads for a minute or two, chances are you're not going to catch that virus. And that is a big misnomer. Somebody thinks that by just touching somebody for 1 second, they can catch the virus, but that is not true. The viral load has to be high enough. Your amount of inhaled load has to be high enough for somebody to actually turn positive. And that's an important criteria to understand when designing spaces. So the flow rates for clean air required can actually be calculated. The Wells-Riley model, I took this from Dr. William Banfleth. His presentation was very interesting about how to design spaces. So the Wells-Riley model has been used extensively during the pandemic. Essentially, it talks about the probability of getting new infections. All the variables in terms of number of infectors, what is the emission rate from each of those infectors, what is the pulmonary ventilation rate, exposure time, and finally the flow rate of uncontaminated air. This was a very, very interesting word that he has used. He did not use the word flow rate of fresh air, flow rate of outdoor air. The word used was flow rate of uncontaminated air. And he put a very clear disclaimer over there that uncontaminated air can be outdoor air, it can be filtered air, or it can be disinfected air. That changes many things, right? So now, if you don't have an option of bringing in outdoor air and ventilating the space, you have the option of using some sort of filtration indoors to ensure that you have some level of uncontaminated air. You have the option of disinfecting the air using the right technologies to ensure that you have uncontaminated air. And that can potentially be adequate from virus transmission perspective. Very, very important point over here. And we'll delve into all of the three in terms of bringing in outdoor air, what you need to do, filtering the air in terms of recirculation, and disinfecting the air. So my favorite part of Calcutta, I used to go for a run over here regularly to the race course right across from Victoria Memorial. So this was a picture I found and I said, my goodness, I can't even see Victoria Memorial clearly. So what do you do when the outdoor air is so polluted? You can't bring this air indoors with a simple mechanical ventilation system. You can't even use a simple exhaust in that space, because when you use an exhaust, you're creating a negative pressure in that particular space. And when you've created negative pressure, it's not going to become a vacuum automatically. It will somehow pull air from outside, from your windows, from the crack under the window or the door. The air from outside is going to come in. And if this is the condition outside, then you're going to be pulling in this air without treating it, and you're going to get exposed to pollutants, which in the short run may be okay from a virus perspective, but from a long run perspective, these pollutants can play havoc to the human body. So what do we do about that? So the answer to that, again, three options. You can ventilate with outdoor air after filtering it properly. You can use recirculation filtration, or you can use a combination of both. My recommendation always is to use a combination of both, and I'll tell you why. So when you ventilate with outdoor air, one of the biggest properties that outdoor air has that no recirculation filtration can actually fix for you is reducing the carbon dioxide levels. All human beings breathe in oxygen and we breathe out carbon dioxide. The carbon dioxide levels in the outdoor air, the ambient air, is about 400 to 430 parts per million. And typically, indoor air CO2 levels are acceptable till about 800 parts per million for an A-grade building and about 1100 parts per million for a B-grade building. Earlier, the standards for ASHRAE used to be 1100 and 1600, but now with more understanding that lower CO2 levels raise productivity of people, lower CO2 levels have even shown to increase test scores in students in schools. Increased fresh air has become the norm in order to improve productivity of human beings. So when you bring in that air from outside, which has 400 parts per million of carbon dioxide, and you push it into a room which perhaps has 1000 or 1200 parts per million of carbon dioxide, you're diluting the carbon dioxide and you're bringing in fresh air. Now, it's important to remove the other pollutants from outside like particulate matter and other gases. But once you do that, then you will have perfect air inside in terms of particulate matter, volatile organic compounds, various other gases, and also carbon dioxide, which is a very, very important gas to take care of. When you have only recirculation filtration, then you can take care of the particulate matter. You may perhaps, if you have the right filtration, take care of some of the gases, but it's impossible or nearly impossible to take care of the carbon dioxide with recirculation filtration. And hence a combination of both works really well, where I can take care, put positive pressure into my space by bringing in filtered air from outside, reducing my carbon dioxide, and using recirculation filters to improve the efficiency and optimize from a cost perspective of cooling and heating. Because when I'm bringing in outside air, it's also very humid, it's also very hot, and I have to spend a lot of money in cooling it. So I want to minimize the amount of outdoor air that I bring in, just enough to keep my CO2 down, just enough to keep a mild positive pressure, and the rest of the filtration I will do with recirculation filtration, which will increase the life of my filters. So the combination of the two is the best. So bring in outside air, but filter it. This is source control. So whether you put a TFA or you have another machine in your, so the picture on the right is actually a machine in my bedroom where I've got a 5-inch hole in the wall. I'm pulling in air from outside. It's going directly into the machine, 4 layers of filters. It's getting completely cleaned in a city like Delhi, which is the world's most polluted capital or world's most polluted city. All the pollutants get trapped in 4 filters inside the machine. And from the top, you see the vents right in the top part over here. The clean air comes out from that machine and it creates positive pressure in my bedroom, and it gives me results all night long with 2 people sleeping. My CO2, when it used to be without this machine, it used to be 2400 parts per million. Now it is down to about 650 parts per million with this machine running. And my PM 2.5 levels are close to 0 in my bedroom, and all the gases are taken care of because I've created positive pressure and I've got filtration for all the air coming inside. Now, in a larger space, I might have a TFA, but I need to ensure that I build in the right kind of filters before I bring in that air from outside. So when I do the filtration, I have to think about what kind of filtration to put in for the particulates. And MERV ratings come in very handy, and they become very important when designing the kind of filtration that I want to put in the space. Now, ASHRAE and ISHRAE have given very clear guidelines that MERV 13 is the recommended filter for air handling units. Ideally, I would prefer to go higher with MERV 14, 15, 16, but typically the challenge comes when you have a pressure drop. The higher you go on the MERV scale, the higher the pressure drop you will have on your filter. Now, a MERV 13 filter will give you about 90%, 89% filtration efficiency for filtering the droplet nuclei. Now, if you're getting 90% efficiency and you can get MERV 13 filters which have pretty low pressure drop, then you can pretty much change your existing filters with a high quality MERV 13 filter without having to change too much in terms of your motor and your fan on your AHU. That is the typical challenge, because if you don't have the pressure drop available, then you can't upgrade your filters to a higher efficiency filter. And a lot of times people find it difficult to change even to MERV 13 filters, but that is something that perhaps can be done. So when it comes to recirculation filtration at the AHU level, you want a minimum of MERV 13 in the AHUs. Again, think about the pressure drop, motor fan, install a VFD if it's possible. And at the occupant level, I would recommend putting an H13 filter, which is higher than a MERV 13. It's typically a MERV 17 or so filter, which is recirculating filters. They can be ceiling mounted or floor standing or wall mounted. You have to check that they are H12 or H13 certified. Proper design and installation are important. Mind the gap. I have seen numerous installations where I've walked into an air handling unit room and I've seen the filters, the typically basic G4 filters are installed on the AHU, and there's a 1-inch gap between two filters. And friends, it's simple. Air moves through the path of least resistance. If you have a 1-inch gap, most of the air is going to try and go through that 1-inch gap. Those filters are not going to be utilized in that sense. So mind the gap, ensure that the filters are installed properly, and all the air is going through the filters rather than any of the gaps over there. So choosing a MERV 13 filter carefully can actually help, because there are the diamonds over here in blue represent the pressure drop that you can get from different filters of MERV 8, 11, and 13 from different manufacturers. So it's very clear that you can get low pressure drop MERV 13 filters, which are equivalent to MERV 8 filters in terms of pressure drop. And hence you can install those in AHUs, which perhaps do not necessarily have the capability to put high quality filters as well. Now, understanding and choosing HEPA filters carefully. This is a very important part, and I want to spend a minute or two on this slide because it's a very important slide. People don't understand filtration very well. When it comes to HEPA, the word HEPA itself is very simple. High efficiency particulate air filter is HEPA, nothing else. High efficiency particulate air. Now, when it comes to a HEPA filter, there are two things that one needs to understand. And I'm going to take a minute and explain it slowly so everybody can get very clear understanding of what this means. First of all, we have to have certification, and there are multiple agencies. One is the EN 1822 certification. There's the ISO 29463 certification, which shows the filter efficiency, whether it's a true HEPA filter or not. Now, what are the two things in the true HEPA filter? How do you determine that it is a true HEPA filter? The first step of the test that they do is to determine something called MPPS. Very important terminology over here when it comes to HEPA filters. MPPS is the most penetrating particle size. MPPS, most penetrating particle size. So first, they determine that based on the particular sample of filter that you give them to test, which particle size is able to penetrate that filter the maximum. Typically, that ranges from 0.1 micrometers to 0.3 micrometers in size. Once they have determined which size is most penetrating, then the second step of this test comes into play, where they take the sample of dust of that exact size, which is the most penetrating, and they force that through the filter at different speeds, depending on the device that they are testing. Now, that most penetrating size at different speeds, what efficiency are you getting in terms of filtration is what is then recorded as your worst case filtration efficiency. So in most cases, a true HEPA filter will have 99.7% or 99.97% filtration efficiency of particles of size 0.3 micrometers, which means that anything smaller than 0.3 and anything larger than 0.3 will have a higher filtration efficiency than 99.97% also. That's a very important understanding. It may be 99.7, it may be 99.97, it may be 99.8, it doesn't matter. Depending on the test, your 0.3 will be at, say, 99.7. Anything smaller than 0.3 and higher than 0.3 will be higher than 99.7. So when people say, oh, it can only do 0.3 microns at this, and hence everything less than 0.3 will go through, that is not true. And the science behind it, if you want to Google and study, it's called the Brownian motion, because of which the smaller particles get trapped within the filter as well. I'm not going to go deep into that science. You can Google it and study the Brownian motion. But essentially, that's the science that traps even the smaller particles, even though the 0.3 will go through a little bit, but the smaller ones won't. Again, leak testing on your device, filter change are things that you have to understand when choosing a HEPA filter, which are important in terms of understanding what is the type of HEPA filter you should get. And because if there's a leak on the machine, the way in terms of the way the filter is installed, then essentially it's going to bypass the filter and you're not going to get a lot of efficiency out of it. So here are the recirculation filtration options. You have ceiling mounted options where we've done quite a few installations with over hundreds of these machines that we've deployed across the country, with in schools in Bombay to offices in Bangalore to large offices in Gurgaon and Delhi. These units have been installed. Even smaller offices with 1122 units in the ceiling have been installed, which give you a very high efficiency because you can do a little bit of extra engineering on this in terms of putting a silencer, in terms of putting a little ducting, so it improves the airflow. So the aerodynamics in terms of the airflow from one part of the room to the other can be improved with these ceiling mounted units because they can be ducted fairly easily. The second option is floor standing portable units. These are easy air purifiers that you can get in the market, but the only key things that you have to understand is get a carbon filter, get a HEPA filter, and a pre-filter, because we have a lot of coarse dust in India. Anything else that you add on to this, an ionizer, bipolar ionization, or photocatalytic oxidation, or a UV light inside these portable cleaners is not something you want to pay for. It's not something you want, because all of these can potentially lead to more harm than actually help you. And the third option is wall-mounted units. We've done many of these as well in multiple locations around the country. In fact, we've done a few in the ministry over here as well, where these go sleekly installed on the wall. Very, very silent units. Noise is another consideration when you're putting units like this in an occupied space. So you want to balance the noise level from a machine like this and the filtration capability of the machine. So just to give you a quick sample, we did the Ministry of Power, Government of India office, and a unit was installed. It was a floor standing unit with wheels that they installed over here in that particular office. The next part is disinfection, UVGI. So one of the things that you have to understand, UVGI has been used very heavily to keep the coils clean from an energy efficiency perspective, but just keeping them on the coils is not necessarily going to ensure that your air is going to be disinfected. Please understand that the air speed, the contact time of the particular virus or bacteria with the UV light, the distance of that particular virus from the UV bulb, and the intensity of that UV bulb will dictate the performance in terms of disinfection. It can be surface or air disinfection. You can have three options, which are upper room UVGI, in-duct UVGI, or even portable UVGI when it comes to air cleaning or air disinfection. It will not kill stuff in the shadows. So if you have UVGI and you've got a shadow, chances are it's not going to be very effective. Implementation is critical. You need a minimum target UVC dose, 254 nanometers or 1500 microjoules per centimeter square to get 99% removal of viruses and bacteria for on-the-fly air disinfection. And ideally, it should be coupled with mechanical filtration as well, because there can be a lot of different things that can happen with UVGI. Over a period of time, the bulb intensity can go down. If it reduces, then it can potentially produce ozone, and it may skip the ability to disinfect the air as well as it should. There are multiple other things that can happen, and so it should typically be coupled with mechanical filtration as well. There are other electronic air cleaners in the market, and I use the word buyer beware with the pun on the word air over there. So there are many, many names, excuse me, many names in the market with regards to these electronic air cleaners, whether it is the photocatalytic oxidation, dry hydrogen peroxide, bipolar ionization, corona discharge, needlepoint oxidation, oxidants, ozonization, magnetic filtration, trap and kill technology. There's Shico-Can, which again claims something similar, but at the end of the day, what they do is all very similar. They basically have reactive oxygen species, ROS, which get released in the air. which are either ozone, hydroxyl radicals, oxidation, which is photocatalytic oxidation, or dry hydrogen peroxide, or superoxide oxide anions. They react with airborne contaminants and they react with everything else in the air. And the claim is that they deactivate the virus and bacteria while actively in the air. So they're called active filtration technologies, whereas everything else that we talked about in terms of MERV 13 and MERV 17 or H13 are all passive filtration technologies. Now, the facts are, buyer beware. Why you should want to be beware of these kinds of technologies? They will produce free radicals and ozone, which is harmful for human health. They are unpredictable in their reaction because they will react with everything and they will potentially create byproducts which can be harmful, including formaldehyde and ozone. And they're unproven to be safe or effective. There's not a single peer-reviewed scientific journal that has been published that in any of the scientific journals on these technologies. Some of them claim to be 10, 20 years old. They'll give you lots of lab reports where they've paid for the labs. But why haven't they been covered in peer-reviewed scientific journals? Because the results are not yet proven. That's the reason. So be very careful. They come out as being very cheap and easy to install, but be very careful before going in for technologies like this. The reason I say be very careful, some of you may know we've got a greenhouse in our building, the Paharpur Business Center, on the rooftop. And you see this little gray box over here. I'm circling it for you. This gray box is an ionizer. And we were told many years ago, this is about 8 years ago, we were told that this ionizer will be very good for removing particulate matter from the air. And we installed this in the greenhouse. For the first time in our life, in running this greenhouse for 20 years, we had all the plants in this greenhouse die. We were stumped. We were not sure what happened over here. And we called in some scientists from NERI, from all sorts of places. And what we finally found out was that this particular device was giving out a very small amount of ozone, which was in the acceptable range. And they don't call it harmful because it's in the acceptable range, but it killed all these plants. If it can kill all these living plants, imagine what these ionizers and active technologies can do to human lungs. So my recommendation is please be very careful, buyer beware before installing technologies like this. They're new, they're cheap, they're easy to install, but they're not necessarily proven or safe. So you can't manage what you can't measure, said Peter Drucker. Making the invisible visible is our job, right? When I started this business of air quality 8 years ago, people would tell me that I was crazy. I've lost my mind. I don't want to do anything for the rest of my life. So I'm trying to sell clean air, something that is not visible. In India, there's a saying, right? Jo dikhta hai, wo bikta hai. But I was trying to sell the invisible. I was trying to sell pollution. But the job of making the invisible visible was something I took on 8 years ago. I had a very expensive device called a dust track, which was thousands of dollars at the time, that I would go to clients' houses and show them the pollution with a number. Today, those thousands of dollars have come down to a few $100 only for a device that can measure air pollution. Now we can measure particulate matter, we can measure carbon dioxide, TVOCs, temperature, relative humidity, sound, light, occupancy, and many other parameters which give us a lot of intelligence about our building. It gives us a lot of intelligence about what we are breathing. These are scientific instruments that have been developed over the years. They've been around for many, many years. They used to be very expensive earlier. Today, they've become very affordable. Buildings are now deploying them by the hundreds. We've done large IT companies in Bangalore where we're deploying hundreds of these kinds of sensors in each building so that they understand what is the air quality, what is the productivity, and how that links to productivity of the people. We're using artificial intelligence and machine learning to optimize the systems better for better occupant health, for better occupant productivity, and also for improving the energy efficiency of the building. When we get to know about the air quality of a building, then we get to also understand what are the systems and the engineering systems in the background that are running based on that air quality, and we get intelligence about that building, and we can optimize. Using that intelligence, we can optimize the entire system to ensure that we can reduce energy and ensure that we can get better health and better productivity from the people. So the best practice for healthy IEQ is design and remediate to ensure that you have good air quality, keeping human health in mind. continuous monitoring of the air quality parameters that we just talked about, and then managing. It's an ongoing process. You cannot just, it's not like an air conditioner that you've just put the air conditioner in place and you forget about it, done. You have to continuously monitor. We have a service in our business where we are constantly monitoring the air quality in our clients' facilities. And the moment we see that the air quality is poor in one room, we call the facility manager and we say, this particular room, the air quality has gone bad. Can you find out what's going on? Has somebody left a window open, or did somebody burn an agarbatti in that room? Something is going on, and we are catching the problem before the client even gets to know about the problem. So that's a proactive way of managing what is going on, ensuring and giving satisfaction to the consumer that their health is our priority, and we are ensuring that we are giving them the best value for their money. So happy to take any questions. Hopefully this was a little bit different, little bit of a different angle in terms of air quality coming from a health and wellness perspective. I would love to take your questions from here.
Nilanjana, are you there with us?
Yes, I'm there.
Okay, great.
I see one or two questions in the chat box as well. So Manish sir has asked, what is the typical life cycle of a HEPA filter?
That's a good question. A life cycle of a HEPA filter really depends on multiple things. Typically, there are 3 to 4 factors that I would look at. One is the surface area of your true HEPA filter, right? So the total surface area, some HEPA filters are about ½ an inch thick, some can be an inch thick, some can be 4, 5, 6 inches deep. And the total surface area of the filter is important to understand. Will be one of the criteria to measure the life cycle of that filter. The second one will be at what speed, fan speed, the air is going through that particular HEPA filter. So the amount, the volume of air that is going through the HEPA filter will determine the life of the filter. 3, the pollution level, the amount of pollutants that you're running through the HEPA filter will determine the life of the HEPA filter. And 4, how many other filters you've put before the HEPA filter. If you've put a coarse dust filter before the HEPA filter, then you will perhaps extend the life of the HEPA filter because you're not choking it with the larger particles, which you will stop with a coarse dust filter. So all of these things will determine the life of a filter. A smart machine will take all of these factors into consideration and then tell you when the filter is ready for change. And an even smarter machine will perhaps put a pressure drop sensor. And once the pressure drop has gone very high and you know that the air is unable to pass through because the filter is choked, it will give you a sensor, it will give you a notification that it's time to change the filter. A good quality filter, a very high quality HEPA filter for example, the one in my bedroom, the main HEPA filter lasts me for about 3.5 years. But a low quality filter typically would have to be changed in about less than 1 year also.
So a follow-up question after that was that how do we get to know that the filter has depleted?
Yeah, so, there are, like I said, a smart machine will tell you when the filter is depleted based on the pollution levels, based on how many filters are there before the HEPA filter, based on what is the speed of the fan you're running the machine, and what is the size of that filter, which they know. And an even smarter machine will tell you based on pressure gauge. At the end of the day, however, as a consumer, I like to take out that filter when the machine has told me, it's given me a notification, but I still like to do a quick visible check of that filter. And the naked eye will tell me that, there are shades of gray and shades of black that you see on HEPA filters. I wish I had some pictures that I could show you of the black and the white, the brand new filter being white and a dirty filter being completely black. We've got lots of pictures like that. I should have put a couple on the slides over here. But when you see that it's completely black, then you know it's time to change the filter as well.
Yes, sir. There's another question. Post-pandemic, is there any regulation offered by the government to ensure and regulate IAQ in commercial buildings?
There is no regulation by the government, unfortunately. I wish there was some kind of regulation. The only thing that we have is guidance documents by ISHRE, which I briefly mentioned during the presentation. That guidance document has been very widely accepted and adopted by many government agencies around the country. And they have used that as a guideline. Unfortunately, it's not a regulation. Uh, Ideally, I think there are technologies which can minimize the risk, and if it would have been regulated, I think we would have seen hugely lower numbers. But there is nothing from a regulation perspective. These are just guidelines that we've seen come out from various organizations like ISHRE.
One gentleman asks here that what are the equipments that you have installed in your house? And is it custom made or the manufacturer can make it for others as well?
Sure. So what I have installed in my house is something that we actually sell. I'm not promoting our product over here in that sense, but essentially the brand that we have is we resell a Swiss product called IQ Air. It comes with a special accessory from Switzerland, which is an optional accessory which allows you to make a hole in the wall, and then it connects that hole with the machine. So it has an attachment which gets attached to the bottom of the machine so that the air is absolutely sealed and tight, and only the air from outside goes through. So that's a Swiss machine. We are the exclusive partners for that company in India. And that is the machine that I have installed in my house in every room. In some rooms, it is good at ducting, but in some rooms, it was not possible to do the ducting with the logistically. So it's just running on recirculation mode. So we have a few of those machines all across the house.
That's great. We have another question. Corona particle size is 150 mm. It can be can you rectify it by using a HEPA filter or UVGI? What type of air distribution system is more suitable for current pandemic situation?
Good question. So yes, the corona particle size typically is 0.08 to 0.12 micrometers in diameter. So close to that 150 nanometers perhaps. And absolutely, yes, a HEPA filter, as I mentioned, the MPPS, the most penetrating particle size is typically larger than 150 nanometers. It is typically at about 0.3 micrometers, which is about, I think, 3000 nanometers. So anything smaller than that has a higher efficiency than 99.7. So even a smaller particle like corona can get stopped by a true HEPA filter. The key over here is that it has to be a certified HEPA filter. There are many companies out there that are using the word HEPA by using all sorts of other terminology, saying HEPA-like or HEPA type or similar to HEPA or equivalent to HEPA, but they are truly not HEPA. It needs to be a certified HEPA filter, and EN 1822 or the ISO certification is very, very important. And then only you can be assured that you will be able to stop coronavirus. Even UVGI, very clearly, even if the particle size is as small as coronavirus, it can definitely deactivate coronavirus. But again, the efficacy is dependent upon multiple factors that we covered in the disinfection slide. You got to ensure that the time that it takes for the air to pass through the UVGI, the intensity of the UVGI, the nanometers, the 254 nanometers in terms of the wavelength of the UVGI, all of them, so the dosage is enough to deactivate the virus particle. So you've got to get that 1500 microjoules per centimeter square of dosage in order to deactivate the virus particle with UVGI. Both of these are possible. If I did UVGI, I would also add a minimum of a MERV 13 filter. Then I wouldn't put a HEPA filter in my AHU. I would perhaps put HEPA filters in my recirculation system in my occupied spaces. In terms of air distribution system, all air distribution, the key here is not, I don't know the answer in terms of which type of air distribution system, but I would say that in terms of the air distribution, the key that I learned recently was that you shouldn't have your supply and return right next to each other. Or if you did some sort of simulation with your air supply and air returns, then you would know very clearly what the air distribution patterns would be, and how the air would flow, and hence how various aerosols in the air which we are breathing out would get distributed within the space. So those, if you do those simulations, then the best kinds of air distribution can perhaps be found. Ideally, it's not easy to do in a construction like India, but in the perfect world, I would say I would get my supply air as close to the ground or 3 feet above the ground, and I would take my return air on the top of my close to the top of my ceiling. So the air will move from the breathing zone where the supply air, which is the cleanest air, is coming in near the breathing zone, which is 3 feet to 6 feet from the ground is the breathing zone. That's when the supply air would come in, and this return would be up near the ceiling, and the air would move upwards, and hence the potential of passing on or transmitting from one person to the other would get minimized completely. Very difficult in construction like India, because we have brick and mortar construction. In construction where you have drywall like the US and wood, it's much easier to have your supply grills in the floor or on the walls on the side, and have your returns higher up in the ceiling. And that's what some of the best ways to do it. It's much more difficult to set up in India.
Okay. So the next question that we have, sir, there are some health concerns associated with UVGI. Could you shed some light on that?
Absolutely correct. So UVGI, the moment you get exposed to UVGI, either your skin or your eyes, it can cause extreme damage to human skin and eyes. So you don't want to look directly into UVGI. So hence induct installations or AHU installations are typically recommended. However, there are some installations of upper room UVGI. Again, it should be done by a practiced by somebody who understands UVGI, by an expert who understands how to do the installation. Because when you do that installation in the upper room, i.e. near the ceiling, then the direct light should not shine on the human beings. There should be something that ensures that the air is passing through the field of the UVGI, but the light is not coming directly on human beings. The portable UVGI towers, robotic towers that are out there, one must be very careful when using them. They're being used in operation theaters and dentists' offices, and it's okay to use them. But when they are being used, you have to ensure that the space is completely not occupied. And they're typically robotic, and they're remote control on and off, so that only when the room is completely empty, then you turn on the machine, you leave it on for 30 minutes or 1 hour, depending on the dosage, and then you turn it off. Then you leave it that way for a little while, and then you enter that room. So you don't want to be in a room which has UVGI shining directly on you. It can be very harmful for you.
That's great. The next question that we have, sir, are you seeing the trend demanding to enhance existing HVAC systems, enhancing filter from G4 to MERV 13, and are the new projects adopting ISHRE guidelines?
The answer to that is absolutely yes. Absolutely yes. Again, it's our responsibility as consultants, as engineers, as providers of technology in this space to educate our customers. And most customers, when they understand this, when they, you give them the right kind of documentation in terms of guidelines from ISHRE, that has a lot of weightage in the minds of people. They realize that it's an organization that gives the right kind of information, and then they are open to listening to the consultant. And hence automatically, of course, cost becomes a major criteria, but it's possible to get MERV 13 filters with low pressure drop, and most AHUs are able to handle that. At most, we will add a VFD to that machine, to that AHU, so that we can even do more in terms of energy efficiency and control the speeds depending on the pressure drop on the filter as it gets stoked. But other than that, we are seeing more and more customers who want to open their offices start to adopt these guidelines from ISHRE.
We have another question, sir. In an existing office, how air quality can be improved? Is it only by changing to HEPA filters, or are there any other means?
So that's okay. So essentially, the entire presentation was talking about that. So there are three ways, right? One is ventilation, one is recirculation filtration with HEPA filters, and the third is disinfection. And you can have a combination of all three, or you can have one, two, or three out of these. My preference is always to use a little bit of ventilation because it will reduce my carbon dioxide levels, because the other two cannot reduce my carbon dioxide levels. So in terms of improving air quality, it's a holistic approach to air quality, and hence CO2 is a very important criteria. Ventilation is very important. And to minimize my energy cost, because if I bring only fresh air, then my cost of cooling and heating goes up, because outside air can be hot, can be humid. In a place like Calcutta, the humidity is very high, and so your cost of cooling becomes very high. So you minimize your fresh air to the minimum amount required to keep my CO2 levels with to the air quality standards. And after that, I use recirculation filtration with HEPA filters to ensure that I get the best results eventually. So it's an optimization, a combination solution of fresh air and HEPA filters to get perfect air quality within the space.
I think we are done with all questions. Okay, we have one last one, sir. Dual stage air filtration or single stage, which can be used in longer span?
I always recommend minimum dual stage. We even do 4-stage, 5-stage, 6-stage, 7-stage air filtration, depending on the outdoor conditions. So very interesting project that we're doing where the outdoor has very high levels of hydrogen sulfide and a couple of other gases that we tested before the building was construction started. So the filtration that we have designed for the space not only takes into consideration the particulates, and we have three-layer particulates, but we also have a double stage chemical filtration built into it to remove the gases and odors from outside as well, because all of that can have an impact on your technology and on the human beings inside the office and eventually productivity.
I guess we are done with the questions. Kamal Sarkar sir, you had your hand raised. Would you like to ask your question directly to our speaker?
Yes.
Yes, sir, please.
Mr. Aggarwal, see, I have got two questions. In a closed building, are you able to hear it?
Yes, sir. Please go ahead.
In a closed building where there are no windows, no openings are possible in an existing building. What is your recommendation for fresh air entry so that to some extent these pollution can be flashed? Pollution means, I mean to say, only the COVID-19 part. That is point number one. And question number two is, this HEPA filter, what you are talking about, is it better to put it in AHU or it's better to put it in terminal? In a clean room application, normally we put it in terminal. Because if you try to put in the AHU, the existing building, the pressure drop may not be able to be met with even with the application of VFD what you specify. So what is your recommendation? At least what should be the minimum fresh air entry in terms of percentage, 1 air change, 10 air change, 3 air change, something like that. And what is the recommendation about putting up HEPA or ULPA or whatever it is, better a terminal or in the AHU? Because terminal we can somehow manage. In an AHU, as you have told, there is a half-inch gap. In case of an HEPA filter, even a 0.5 millimeter gap, 1 millimeter gap also across two flanges, it will make all the difference.
Absolutely.
So what
Absolutely.
is your kind recommendation on that, please?
Sure, sir. So, we've done lots of buildings which are glass buildings, and there's no opening of windows possible in a lot of these new buildings that are being made. But invariably, they have some sort of shaft or some sort of way to bring in fresh air where the AHU rooms are designed. So ideally, you bring in the fresh air from the shafts of the AHU room and bring in that fresh air through that particular space. We have come across one or two places where there's absolutely no possibility. In that case, either there is some amount of civil work that we have to get into in breaking of the building to bring in. At the end of the day, we need a hole in the wall to bring air from outside. If you cannot give me a hole in any way, form or fashion, then it's not possible to bring fresh air, right? If you say no windows can be open and there's no opening whatsoever from outside, then I have no option but to only do recirculation filtration, and ventilation is not possible. But at some point, most buildings have designed some sort of fresh air intake, whether it's the AHU, or there are shafts, or there are some pipeline shaft, some other shaft is there, and we are able to find some engineering solution, out of the box solution sometimes to get that done. Sometimes we'll even take ducts from outside the building. We'll do cladding around the ducts, and then we'll do a small cutting in the different floors to bring in the inlet of the duct from outside the building. So there are multiple ways to slice that particular problem. With regards to your HEPA filter question, I would say you're absolutely correct. Putting a HEPA filter in the AHU is typically not feasible because of the pressure drop issue. Your pressure drop on a HEPA filter is too high, and most AHUs cannot handle that. Now, either you say that you upgrade the entire AHU, which typically is for a retrofit is not cost feasible. It's the ROI is not there, especially if the AHUs still have some life left to them. So typically in the terminal, or like I showed some pictures of ceiling mounted recirculation HEPA filters, or even floor standing HEPA filters or wall mounted HEPA filters can be installed very easily. At the end of the day, the key is to achieve 4 to 6 air changes per hour with regards to your uncontaminated air. And that was a very important line that was there in one of the slides. Uncontaminated air doesn't have to be fresh air. It can also be filtered air, and it can also be disinfected air. So if I can total amount, including my ventilation air, plus my recirculation air from the HEPA filter that may be on the terminal or the ceiling or the wall or on the floor, my total air changes can be 4 to 6. Then I have minimized my risk with regards to COVID-19 in that space.
Thank you very much. That answers my question.
Thank you, sir.
Barun, excuse me, can I ask you one question?
Of course, sir, please.
That is, you are talking about 4 to 6 air changes of uncontaminated air. Now, basically, to get rid of the contamination, you are talking about HEPA filters or filtration. When we talk about filtration or use of HEPA filters, that normally takes care about the particulate matter. But contamination of the air is not confined to particulate matter only. Some other things are also there which contaminate the air. So how those will be taken care?
Absolutely right, sir. So I like to classify the contaminants in broad buckets. The first bucket is particulate matter. We've addressed that with the HEPA filter, with the ventilation also, with which will have some sort of filtration. The second bucket is gases, like you can have outdoor pollutants like sulfur dioxide, nitrogen dioxide, ozone, SOx, NOx, ozone. So for that, wherever you are bringing in the air from outside, at that level, you have to put some sort of chemical filtration, excuse me, in order to remove that NOx, SOx at source. You don't want to bring it into the office and then clean it with filters. Ideally, you want to clean it at source. Again, if it's not possible to clean it at source, then you have in your recirculation machines, we have, for example, in our recirculation machines, we have very heavy duty activated carbon filters with potassium permanganate built into it. And that absorbs a lot of your SOx, NOx, and ozone as well, a little bit of the ozone as well. The third pollutant in my category is TVOCs, total volatile organic compounds, which are typically created indoors. From your carpets, your paint, your furniture, your wood is off-gassing constantly. Now, one of the best ways to reduce TVOCs is ventilation, fresh air dilution. There are some filters that claim to remove VOCs, but in my opinion, the best way to reduce VOCs is ventilation. Fresh air will reduce your VOCs better than anything else. And finally, the main problem that we don't address enough is the last bucket, which is carbon dioxide. And there is one solution, which is a mechanical filtration solution for carbon dioxide. There's a very special patented sorbent, which is available in the United States, We've deployed that product in India in 2 facilities only, but it's a very high cost product right now. So the return on investment is not there, but it absorbs carbon dioxide. It has been used in submarines around the world. You can imagine a submarine stays underwater for many, many weeks and months sometimes. And the CO2 levels in a submarine go very, very high. So they have this technology in a submarine to absorb CO2 and throw it out into the sea. And that technology has been commercialized by a company in the United States to absorb CO2 from recirculation air in the AHU. Not yet feasible from a cost perspective in India. We've tried it out in a couple of sites, but it's promising. I think in the future it has merit. So the easiest way other than that is 2 ways. One, what we've done in Paharpur Business Center, you create a greenhouse with lots of plants, and the plants will absorb carbon dioxide and give us oxygen, and we eat in the oxygen and give out carbon dioxide. So symbiotic relationship with plants can be created within office buildings, as we've done in Paharpur Business Center with 7,000 plants. And the second is bring lots of fresh air from outside to dilute your carbon dioxide. So these are the main ways of addressing all the pollutants.
That's good, because in that case, this fresh air intake with proper filtration, that is going to give the best answer for all these combinations. Although there will be some temperature rise of the air, that is in the conditioned space, if we take more fresh air, either we have to sacrifice with the temperature rise, because now as per the guidelines or manuals, even in the COVID situation, we should keep the temperature between 24 to 30 degrees centigrade. Correct. And relative humidity between 40 to 70%. And mainly a place like Calcutta, we should try to keep the temperature around 24, 25, because we have the higher humid. Place which is higher humid, there we should try to maintain the lower temperature so that moisture removal and we can remove it. Absolutely. So that is the solution is coming out. That the main thing is we should put more and more greeneries in and around the building so that we can have the less polluted air. Okay.
Absolutely, sir. Correct.
We are done with the question answer session. Thank you so much, sir. I now invite Mr. Indrajit Saha, Treasurer of Kolkata chapter, for the formal vote of thanks.
Hi, good evening all. Thank you to Mr. Barun Aggarwal on behalf of Kolkata chapter for the nice presentation. It was really very informative and very quality presentation, which will be beneficial for all of us. I would like to thank you, our President Emeritus, Mr. Manoj Chakravarti, for gracing the session with his presence and valuable inputs also. I would like to thank our President, Mr. Manish Tiwari, and the President-elect Nilanjana Mukherjee also for the presence. Last but not the least, the attendees who have joined today for the participation and the nice interaction post the session. I thank you all of you for the participation. Our special thanks to our sponsors, ALP Group, Lloyd Insulations, Compromise Group of Companies, and Universal Cells. Thank you, Kolkata chapter, for organizing this nice program, and we look forward to see many more of that. Over to Amitabh or Nilanjana to conclude.
Thank you so much, Indrajit Da. We are now done with the session. Thank our speaker once more for joining the session. Thank you so much for sparing your time, everybody. And we'd request Backend to end the session for everybody.
Thank you.
Thank you for having me again. Pleasure to do this. Thank you, sir.
Thank you, sir. It was a really pleasure hosting you. Thank you very much.
Thank you, sir. Thank you very much.
Siddhartha, please close the session for everyone.